let's talk about derivatives and the limit definition of derivative and what the heck is that. So we have a secant line here. It's intersecting the parabola in two places. Hopefully you guys got that. That's what a secant line does. It's a graph that intersects, it's a line that intersects a graph in two places. Throw back to geometry. And a secant line is basically finding, this is something we'll talk about more and we'll take some notes about it, but a secant line finds the average slope between 2 points, or the average rate of change. And so we can have, secant lines where the slope is 0. We can have negative secant lines. It's basically just calculating the slope between 2 points. And that's a topic we'll get into a lot more. Don't worry. So we can, again, this would be the average rate of change between these two places. And notice it's really close to the slope of the curve, but a curve, since it's curved, doesn't have a slope exactly. But we could calculate the average slope between those 2 points. This secant line with the points, the x values and the y values getting closer together, is what it's going to do is it's going to estimate the slope, quotation marks, of this curve a little more accurately because those points are closer together. And so what, pretty sure it's the next slide, what a derivative is a derivative is the slope at one point, one instant, which we can see if we actually try to take the slope at one instant, it's undefined because we would be doing the slope formula, y minus y over x minus x with the same numbers. So we would be getting 0 over 0. And so we're not actually able to take the slope at one point using the slope formula, but what a derivative is talking about is as we approach the same point, we can see that the slope also approaches a number from both sides. So the farther we are away and then get closer, what number is this slope approaching to? And so we are able to say, okay, the instantaneous slope, the slope at that one point, or in this case, this would be the slope of a tangent line, because it's only intersecting at one point, is 2. Even though we can't use the slope formula to calculate it, we can see the limit that the slope is approaching. And that's what a derivative is. It's the instantaneous slope. It's the slope at one point, the slope of a tangent line. I hope you guys took a moment and let that sink in as you were doing this, because this is a milestone in your math career. So I hope you guys are taking this, really sitting with that. And I hope the rest of your day is different as a result. But here's the idea of a derivative. We have 2 points, 2 x values, a and b. And so we have 2 y coordinates, f of a and f of b. And as h gets smaller, the distance between our x's gets smaller, our 2 x coordinates, a and b, get closer together, our slope starts to approach whatever the instantaneous slope is. And so as we look at these are all true choices here. So, yeah, I can fit it all on the graph there maybe. As b approaches a, can I move this one? Yes. As b approaches a, we are looking for the limit of the slope. This is just the slope formula, y1 minus y2 over x1 minus x2. So as b and a get closer together, what does the slope approach? This is just a different way of saying the same thing here. As h approaches 0, so as this distance between the x's gets smaller, this is still the slope formula. B is the same as a plus h, like a is here, and then we add h to it, and there's b. So that's also a way. Again, it's the slope formula. It's a limit of a slope formula. That's what this is. And this is like how we describe a derivative. F prime of a, F prime, that's how we say that, by the way. Oh, it says it right there. Great. It represents the slope of the tangent line to the function. So it's the limit of a slope as it approaches basically no change in x or y, which becomes the slope of the tangent line. And we're going to look at some different ways of talking about that throughout this year. But right now we're just talking about in terms of limits. So bad news for AP Pre-Calc folks. Yes, there are shortcuts. No, you can't use them yet. You get to use them in a couple weeks. So no power rule, no product rule, no quotient rule. Sorry. I'm not sorry. You have to learn it this way first. It's part of it. So this is how we actually compute it. We have this formula, and we'll write this down in the notes, so fear not. But as we're approaching 1, we can see right here that our point is approaching 1. And we are starting to see what the slope is approaching. And we can see our answer here is 2. We'll actually walk through this process here, so I don't really want to point it out on this Desmos slide. We'll do it together. So in case that was just like, whoa, that's a lot of math. You're right, it is. We'll do it in our notes. Don't worry. Jerome's mistake. Hopefully you guys found it. He cubed it wrong. He distributed that cube. Can't do that. Anyways. These two I told you we'll do later, but it's the same idea. We're trying to see this blue line here. We're trying to calculate what slope is that approaching. And we're going to use this limit definition of a derivative. So we'll come back to that. And we'll come back to this. Again, same idea though. Whoa, no. Same idea. We're trying to figure out the slope of the blue line as those 2 points get closer and closer together. Okay. So slope of a tangent line can tell us a few different things. So the green, when it's green, it's telling us the slope is positive. It tells us the function is increasing. When it's red here, the tangent line has a negative slope and shows us where the function is decreasing. And when it turns black, what is it? Why is it turning black here? Yeah, it's when the slope of the tangent line is 0. And what does the blue graph have at those points? Yeah, extrema, yeah, a min or a max. Yes, exactly. So that's an important feature of derivatives. Okay, so let's write some things down. We're just going to write this down on paper. So that picture may be helpful.
Yeah.
So we basically have three different versions of a definition of a derivative. Two of them we call the h way because they're over h, and there's h approaches 0. The third one we refer to as the a way because it has a in there, and I know the second one also has a. Sorry, but there's only one version for the a way. But the key here is that all three of these represent limits of the slope formula from algebra 1, or before, honestly, as those coordinates, as those 2 points get closer together.
What is that symbol supposed to say between y2 and 1?
It's an and sign, ampersand. Okay, I'm gonna leave that right there for a sec. So I'm gonna say this is always helpful for me, knowing what f prime of a actually means. I think that's for right now. F prime of a represents the slope of the tangent line. To f of x at x equals a. Oops. Okay, so you want to memorize both of these statements. Let me just say them again. F prime of a represents the slope of the tangent line to the function f of x at the x value x equals a. So this is like a numerical slope, like 2/3, 1/2, 2, something like that. F prime of x represents what we call the derivative of f of x, which is a function that tells us the slope of a tangent line to f of x at any x value. Meaning we could plug in x and it would say, we could plug in 2 and it tells us the slope at 2. We could plug in -3, it tells us the slope at -3. The a way can tell you f prime of a, but it cannot tell you f prime of x. The h way can also tell you f prime of a. The h way can tell you f prime of x as well. It can give you the whole function. So again, going back up to the 3 different versions, notice what each one of these gives you. There's one version of the h-way that gives you a whole function. So if it says like find the derivative, you would use the h-way. And then there's 2 ways to find f prime of a specific slope at a specific point. And both versions, the h-way and the a-way, can do that. So depending on what you're being asked to do. There may be a question on the quiz or a test where I tell you you have to use the h-way or the a-way specifically. So you need to be familiar with both of these. And we're going to get familiar with both.
Wait, does the A-way apply to the like, so if the H-way applies to the first 2 and the A-way applies to the last 2, does that mean the middle one can be applied to both?
No, that's the first 2 are called the h-way.
Oh.
That's just how I'm referring to it. Yeah, it's the same thing, just with a plugged in. So because it takes too long to like read out the whole thing, right?
Yeah.
So that's just what we name them. Okay, so let's look at some examples where we actually do this. Sometimes this process can get long and tedious. That's okay. Sometimes it's fun. We are going to learn a bunch of shortcuts to avoid doing this in about a week and a half. So there's good news, I guess, if you don't like doing this. But it is important that we learn it this way, as sort of setting the foundation for what the heck's going on. What do derivatives mean? This is what they mean. Okay. So we are given a function here, 2x. And we want to find f prime of x. So if we're looking for f prime of x, we are looking for a function that represents the slope of the tangent line at any x value. To find f prime of x, we can only do it one way. Which way? The h-way. Only the h-way can find f prime of x. So I'll just write it down here because for me it's on the previous slide. For you it's probably on the same paper, so you don't need to rewrite it if you don't want to. Whoa, that's not how you write it. There we go, that's how you write it. So here's how we do it. We're going to plug in x plus h into f of x. So it's 2 times x plus h. We're going to subtract f of x, which is 2x. And we put that over h. When we do this, like, we're going to get 0 over 0. Just a reminder, never write 0 over 0. Because 0 over 0 is not a real number. It's nothing.
Why can't you just write 0 then?
Because it's not 0.
Oh.
Yeah, it's nothing. So what we need to do is we need to simplify it, just like we did last week with all our different limit techniques. How would I simplify this one?
I distribute the 2 for them.
Yeah. So 2x plus 2h minus 2x. And we can see that those 2x's are going to cancel. Again, this still is going to give me 0 over 0. Right? I need to keep simplifying. Okay, so we get 2 as our answer. I want you to turn to your neighbor. What does this mean? What does that tell us about what's going on here? And start your sentence with this. The slope of the tangent line . Okay. How would we finish this sentence? The slope of the tangent line is equal to 2. Where? No. We got 2 as our result for f prime of x. Remember, this is f prime of x. What does f prime of x represent? A function to tell us the slope of the tangent line to our original function at any point. So what does this mean? The slope of the tangent line is equal to 2 at all x values. Yes. The slope of the tangent line is 2 everywhere on this function. What was the original function? 2x, right? What's the slope of the line 2x? 2. So does this make sense? Yeah, it does. No matter what, we can't actually draw a true tangent line here because it would just coincide. It would overlap it completely. But at all points, our slope of the tangent line is 2. Okay. So again, it's always important to know what is going on. What do we mean when we get 2? Like, what does that actually mean? All right, we're going to do another one. Okay, so we're looking specifically for f prime of 2. We're looking for the slope of the tangent line to that function, which is a parabola, at x equals 2. Which way could we do to do this? Okay, both. Yes, we can do both. And, good news, we will do both. Okay, take a couple minutes and try this out and see where you get. Basically what you're going to do is you're going to plug in what we have into the limit formulas that we have, which I'll write here for your convenience. Nope, that's not right. So a equals 2 as well, in case you weren't sure. Goal here is basically substitute in those things and then simplify, and stuff should cancel. Okay, so let's take a look at these. Morning. Our function here is 3x squared minus 7. So we need to plug in two plus h in for x, and we need to plug in 2 for x. What I might suggest here is just quickly look and evaluate f of 2. What does f of 2 equal? 5, yeah. So that's f of 2. We're going to need that for both. That way you don't mess it up too much with negative signs there. Okay. Our next step would be to multiply that 2 plus h out. Notice my limit notation is still here. Don't be like Jerome. That's his name, right? Or Jeremy? What was it? Jerome. Yeah. We need to actually FOIL that. So this becomes 3 times 4 plus 4h plus h squared minus 12 if I combine like terms on the outside there. And then I'm going to go ahead and distribute that. And what's happening is what's supposed to happen. That the numbers without h should cancel. And then we're left with something where h can cancel. So this is similar to stuff that we were looking at last week. We're just simplifying now a complicated limit. It's the same idea. Oops. 12 plus 3h. And so when we plug in 0 for h, we just get 12.
What happened to the h at the bottom?
We h simplified. We reduced it. Divided. Okay. Questions on that process? David.
Would you write for like the end statement, because you have to plug in 0 for h,
Mhm.
would it change like, because last time you said, well, like the slope, you're hanging on to for all x values is 2.
Oh, the statement at the end. Yes, I like that you're asking it. Yes, it would change. We would say the slope of the tangent line to our function f of x is 12 at x equals 2. So it's not at all values, it's just at one value. Yeah. And so here's a little sketch of what this could look like, because 3x squared minus 7 is a really steep parabola that's shifted down 7. And so around roughly x equals 2. I mean, that's an estimate of what it would look like. But we see we have a very, very steep tangent line, slope of 12. Yeah. Yes, thank you for asking that. And that means we should get 12 when we do it the other way as well.
Where the f2 equals 5 came in, or will just be given to you?
We plugged 2 into f of x. Our function was 3x squared minus 7, so we plugged 2 in. 12 minus 7. Okay, so when we do it,
So that means f of 2 is 5.
yes.
So
So
we plug is it f of 2, right?
f of 2 means plug 2 in for x right there. Okay, so when we do it the a way, it's f of x minus f of 2. F of x we have already, 3x squared minus 7. F of 2 we know already, minus 5. And then our goal is to simplify this. Often this one is a little bit easier to simplify. A little less complicated than the h way. How would I simplify this?
Take 3 out.
Yep. Take out a 3, and then,
Difference of squares.
yeah. And now we can plug in 2 for x. And we get the same result, which is good. The slope of the tangent line to 3x squared minus 7 is 12 at x equals 2. And again, another way to say that is f prime of 2 equals 12. So that's the idea. We have to plug in what we're given and then simplify. And something should cancel out. Something should always cancel out, whether it's h canceling out or the factor on the bottom should cancel out. Okay, we're going to do 2 more examples. They're the ones from the slides on Desmos. So if you wanted to look back at it later, you could. You could also just number these 3 and 4 if you don't care to look back. That's fine too. So take a couple minutes to do these. I'll tell you what, in number 9, you are going to have to multiply by a conjugate. But you just saw that on your quiz last class, so you're extra prepared to do that. And this one, you're going to find a common denominator. Okay, in the interest of time, let me show you the answers here. Don't start packing up yet, though. Just please follow along with this work. It's a lot. But let me walk you through it here. Let's just look at that one for a sec. So, for the first one there, what we need to do is a is 3. So we're doing f of 3 plus h minus f of 3. When we plug in 3 for x, we get, it's the square root of 4, so we get 2. And when we plug in 3 plus h, we get the square root of 4 plus h over here. So it's root 4 plus h minus 2 over h. So we need to multiply by the conjugate, which is root 4 plus h plus 2 on the top and bottom. Remember, when we multiply by the conjugate, we actually do not want to distribute the h on the bottom here. We want to leave it unmultiplied. On top here, we get 4 plus h minus 4. Those 4's cancel out. And we're left with h over h times the conjugate. Sorry, it's kind of cut off by my screen there. There we go. 4 plus h plus 2. When the h's cancel out, it's 1. We get 1 on top, not 0. 1. And then when we plug 0 in for h, we end up with a slope of the tangent line of 1/4. So once we plug it in, it just turns into multiplying by the conjugate, which is complicated, yes, but we've done it. This one here, we need to do f of x minus f of 5 over x minus 5. So it's 2 over x minus 1 minus 2 over 5 minus 1 over x minus 5. We need to find a common denominator there, which I did in the red, which is a little crazy looking, but there it is. When we find a common denominator, on top we are left with 4 minus x minus 1 over x minus 5 times the common denominator. And again, we don't multiply that because we actually end up with 5 minus x on top. Hold on, guys. We end up with 5 minus x on top, which cancels out with x minus 5 to get negative 1. And that's how we're able to get our slope of the tangent line of negative 1/8. We are going to have a quiz next class, and this is going to be on it. So you have some delta math. Make sure you're doing it this way. If you have questions, come to Warhawk Time tomorrow.